ladies and gentlemen.
So let's talk similarity. We talked congruence in the last video, and the definition of congruent is if we have two shapes and we can translate, we can rotate, or we can kind of reflect two figures onto each other, or a combination of those, and get them onto each other, they're congruent, which means that all of their sides are the same length and all of their angles have the same measure. Similarity is a step forward from that. If we take the rotations, the translations, reflections, and add dilations, this idea of scaling, really scaling up or scaling down, we get similarity. So you can think of it as we have a scaled copy of another shape. What this means for us, though, the properties of two figures that are similar, kind of like we got properties for congruence, is we get proportional sides and we get congruent angles again. Let's look at each of the individual properties on their own that we can get from similarities. First and foremost, a similarity statement looks kind of like a congruent statement. Remember, the congruent symbol is like an equal sign with a little squiggly on top. If we remove the equals and we keep the little squiggly or the tilde or whatever you want to call it, we get a similarity statement. So this in English means that triangle ABC is similar to triangle DEF. And what that means for us is that all of the angles in the same position are congruent, and if we divide the sides in the same positions, then we should get the same number if we're consistent. And I've kind of done it two ways to show us. If I take the A's and I make sure that all the sides for the ABC triangle are on the numerator, I should get the same number. And if I flip that, if I make sure that all of the DEF sides are on the numerator for here, I'm going to get the same number for these three, and we'll have reciprocals between the two. How do you find scale factor? This is how I kind of tell my kids how to do it, or teach my kids how to do it. Scale factor is found by dividing the new side, the side that you're wanting, the length that you're wanting, the triangle you're wanting to move towards, divided by the old quantity. So new scale factor is new over old is kind of how they've remembered it. If you don't have all of this information right now, like without any shortcuts, similarity is, you know that two figures are similar if all of their sides are proportional and all of their angles are congruent, or corresponding parts are congruent. Just like with triangles, though, we can have some shortcuts so we don't have to have all 6 pieces of information to say that two triangles are indeed similar. The first would be angles. If we have any two angles that are congruent between the two pairs of corresponding congruent angles, then the triangles have to be scaled copies of each other. If you don't have the same two angles, if one of them is the same and you're not sure about the others, remember that there's 180 degrees in a triangle, and you can always use that to help you if you don't have a second one, but it looks like it could work. Try seeing if you can find the third angle and seeing if that matches the second angle in the other triangle. I know, rant done. So let's use that here. So we're going to find the value of x here, and we're given some parallel lines. How do I know they're parallel? If you're ever given little arrows like this, that means that those two lines are parallel. Previously, we learned some angle relationships with parallel lines. First and foremost, I know that this angle here and this angle here are congruent because they are alternate interior angles. Similarly, I know that this angle here and this angle here are congruent because they're alternate interior angles, which means that the big triangle at the top and the small triangle on the bottom are similar, which means that they're scaled copies of each other. So I can clearly see that this 6 side is being turned into the x. My question would be then, what is turning into the 4? Well, the 4 is touching the angle with one mark there, and so is the 7. So the 7 is turning into a 4, and in the way the 7 does that, the 6 will turn into the x. Scale factor is new over old, Our scale factor here is going to be the 4 divided by the 7 because the 4 is the new number and the 7 is the old number. And what we're going to do is going to multiply this scale factor by the 6. So 6, because it corresponds to the x, times the scale factor of 4/7. 6 times 4 is 24/7. And that is irreducible because 24 and 7 have no common factors, so we're going to leave that as our answer. So not too bad. Something else that might show up is if you have something like this, a triangle within a triangle. So you can see that they gave us that the bottom sides of these two triangles are parallel. And in doing so, they kind of gave us, like in the last problem, two similar triangles. So we know that this angle and this angle are congruent, not because of alternate interior though, but because of corresponding angles. And this one are also congruent for the same reason. So the scale factor should be the same. Now there's two ways to do this problem. You can view this as cut up pieces, or you can view this as two separate triangles. So let me show you the separate triangles first, and then we'll go back to viewing this as two separate pieces. So the first thing I'm going to do is I'm going to copy the problem over so we can work with it. So we have this triangle. I know it's beautiful. And then we have this triangle here. Again, it's going to be super beautiful. So then we're going to move this triangle over. And we're going to label all of our sides. So we have 6 and 7. We have 6 plus 5, which is 11. And then we have x plus 7 here. So we are going from the small to the large. So 6 to 11 is our scale factor. So our scale factor would be 11/6. So this scale factor is also going to be 11/6. So what does that mean for us? That means that 7 times 11/6 is equal to x plus 7. So 7 times 11/6 is 77/6. And now we can subtract 7 from both sides. Now, how do we subtract with a fraction? You got to make sure you have common denominators. 6 times 7 is 42, so we have 77 minus 42 over 6. And 77 minus 42, well, 2 minus 7 is 5, 7 minus 4 is 3, so we have 35/6 is our x. Wonderful, beautiful. Not too bad. A little bit of algebra there. Something else that we can do is, because these two triangles are indeed proportional, they're cut proportionally as well. So the scale factor that would take 6 to 5 is also going to take 7 to x. So let me make some room here. I'll just move that over. So 6 to 5 would be a scale factor of 5/6, which means that we're going to multiply the 7 by 5/6. 7 times 5 is 35. Ooh, that should be a 6. So 35/6. So we end up getting the same answer. I know it's a little messy now, but you get the idea. But we end up getting the same answer either way. So whichever way worked for you, use that. So if we end up having a similar situation to before, where we have parallel lines, we don't actually need triangles to know that they are being cut proportionally. So if we have a series of parallel lines, like we have 1, 2, 3 parallel lines here, they are going to be cut proportionally. So whatever takes 6 to 18 should take y to 2y plus 3. So the scale factor would be 6 to 18. That would be 18/6, or that would just be 3. So our scale factor is 3 here. So 3 times y, so 3y, should be equal to 2y plus 3. Well, doing a little bit of algebra, we subtract 2y from both sides. We end up with y is equal to 3. So not too bad. Just got to remember proportionality helps out a little bit. So if you have a right triangle specifically, and we draw an altitude for the right triangle, meaning that we take a vertice and we drop it down so it intersects the opposite side at 90 degrees, that makes a similar triangle to the original. In fact, the two triangles formed from the slit are both similar as well. So the two small cuts and the hole together are all similar to each other. So we can use that to solve a variety of problems as well. So let's look at this one here. So what is the value of x? We have a right triangle that's been cut by its altitude. So we end up having two triangles. We have this triangle here, and then we have this triangle here. So we're going to take this one down, and then let's write our information. So this was x, this was 16, this was 3, this was x, and if we notice, this is the larger of the two angles. So this one's 90 and this one's 90. But this angle is the larger angle of this triangle, which corresponds to this angle here. So the angle across from 16 in the medium triangle, kind of the whole thing together is a large one, is the same angle that is across from the x in the small one. So that's going to help us out with our proportions. Since the 16 is across from this angle and x is across from this angle in this triangle, we're going to put them together. So I'll say that 16 over x is equal to, and since I took 16 from this triangle, I'm going to take the x from this one. This would be the small angle. So that's x on the small one, and that would be across 3 in, it's x on the medium one, and that would be across from 3 on the small one. So we get this arrangement. We get 16 over x is equal to x over 3. So what we're going to do here is we're actually going to, solve this equation. So how do we solve this? If your brain went to cross multiply, you were taught some bad rules. I don't like that. We're going to multiply by the least common denominator, which would be times 3x times 3x, because the least common denominator between x and 3 is 3x. When I multiply these together, the 3's will cancel, so x times x is x squared. And then here, if I multiply these together, the x's will cancel, so 3 times 16 is 48. So we have x squared is equal to 48. We square root both sides. We get the square root of 48 is equal to x, and the square root of 48 can be simplified. 48 can be broken down into 16 and 3. The square root of 16 is 4, so we have 4 square root of 3 is equal to x, and that is our answer. So, hopefully not too bad. The main takeaways are that parallel lines cut transversals proportionally, and that if you have two congruent angles in a pair of triangles, then those triangles are scaled copies, our dilations are similar to each other. If you have any questions, please let me know. Otherwise, I look forward to seeing you in the next video.